The next topic to go into involves something called matrices, determinants, and Cramer's rule. And all of these topics are going to go back to the systems of linear equations and how we go about solving them. So this is sort of a new way of approaching the solving in a different manner that might be easier in some cases. The first thing to look at is something called a determinant. A determinant goes along with something called a matrix. A matrix is like an arrangement of numbers into rows and columns, kind of like a grid of numbers. For instance, a matrix might look like 1, 2, 4, 5 arranged into rows and columns. So it's like we have here row 1 that contains the negative 1 and 4, and row 2 which contains the 2 and the 5. And on either side of these I put big brackets on either side. And when I do that, we call it a matrix. A determinant of a matrix looks the same, but instead of putting brackets on either side, we just put straight lines. So we might have same numbers, but when I put bars on either side, that indicates a determinant of a matrix. So the first thing we're going to talk about is how we calculate the determinant of a 2 by 2, 2 row, 2 column square matrix. So the way we do it is kind of outlined over here. We kind of do this diagonal multiplication to make it work. Let me illustrate it on this determinant here. The first step is to multiply diagonally down and to the right. So multiply those two numbers together. Negative 1 times 5. Then the second thing is we multiply up diagonally toward the right, and we subtract those numbers multiplied together. So the next thing is minus the 2 times the 4. Okay, so that's going to equal to negative 5 minus 8, and that's equal to negative 13. That's the value of this determinant. So let's look at a few more examples of determinants. Let's start out with the determinant that has 5, 6 in the first row and 7, 3 in the second row. The first thing I'll do is I'll multiply down diagonally. So we'll multiply 5 times 3. And then the next thing is we'll subtract, and we'll multiply the numbers up diagonally. So I'll multiply 7 times 6. So that would be equal to 15 minus 42, which would be equal to negative 27. So let's try another one. 2, 4 in the first row, negative 3, negative 5 in the second row. And if you'd like to practice this on your own, go ahead and pause the video, and in a few seconds I'll come back and work it through. So the first two numbers that I'll get multiplied together are 2 and negative 5. Okay, and then the next thing is we subtract the next two numbers, the negative 3 and the 4 multiplied together. So that would be equal to negative 10 minus negative 12, or plus 12. So that would be equal to positive 2. So here's where we can take this thing called a determinant and make it work for solving for variables in this system of linear equations. Here, a system of linear equations in two variables. And this is called Cramer's rule. So it sets up with two determinants. They call it dx and d. For solving for x, we divide dx divided by d. And so how this works is we have a column for x and we have a column for the y's within our system of linear equations. The a's are the numbers that are the coefficients of the x terms, b's are the coefficients of the y terms, and c's are the constants. The determinant d stands for putting the coefficients for x down the first column and the coefficients for y down the second column. dx stands for taking the first column for the x coefficients and replacing them with the constants c. So the x column gets replaced when we have the determinant dx. And now to solve for y, we do dy divided by d. dy stands for the determinant where we take the y column and replace it with the constants from the two equations. The first column for x stays the same as the x coefficients in the system. So if we do these calculations, if we work out these three determinants and then calculate dx divided by d, dy divided by d, then we can calculate the values of x and y. So let's work this system through and solve for x and y. 5x minus 4y equals 2 and 6x minus 5y equals 1. So remember that Cramer's rule tells us that x is equal to dx divided by d, where d stands for determinant, and y stands for dy divided by d. So let's do the Cramer's rule for both of these. We need to calculate the determinant d, the determinant dx, and the determinant dy. So what I'm going to do here is set it up with the x coefficients and the y coefficients. Down the first column I put 5 and 6 for the coefficients of x. Down the y column I put -4, -5 for the coefficients of y. When I do dx, I take the first column, and instead of putting the x coefficients, I put the constants 2 and 1 down that column. -4, -5 still stay for the y column. When I do the determinant dy, I'll put those constants 2 and 1 down the y column. So that letter again is just telling me which column to put those constants in, the x column or the y column. Now we can calculate these doing the way we had started out with determinants, multiplied down diagonally, 5 times -5, minus, multiply up diagonally, 6 times -4. So that's going to equal to -25 plus 24, and that's equal to -1 for that determinant. Now when we do the next determinant, we multiply down to the right, so we take 2 times -5 minus 1 times -4. So that's going to equal to -10 plus 4, -6. Now we multiply down diagonally, we get 5 times 1. Multiply up diagonally, minus 6 times 2. So that's going to be 5 minus 12, and that will equal to -7. So now we have d, dx, dy, and we put these into Cramer's rule, dx over d, so -6 divided by -1. That would give us +6 for x. dy would put -7 divided by -1, and that gives us +7 for y. So now we have our solution for both x and y, 6, 7. And we didn't really have to touch the equations to make this work. Cramer's rule is just a way of calculating it via these determinants to get to the solutions for x and y. Okay, now having seen how to do Cramer's rule in one example, if you'd like to try setting one up on your own and seeing how it goes, you could pause the video here, try to set it up with Cramer's rule, and solve. And when you start back up, I'll go ahead and solve it through. So again, Cramer's rule says that x is equal to dx divided by d, and y is equal to dy divided by d. Capital D again standing for determinant. We set up the determinant d by taking the coefficients for x and the coefficients for y. So down the first column I put 5 and 3. The other column I put 4 and negative 6. And then when we do dx, the x stands for the column that I put the constants in. So 12 and 24 go down the first column. 4 and negative 6 stay in the second column. Now for dy, we put the constants down the second column. So 12, 24 go in the second column, and 5 and 3 go in the first column. Now we'll calculate each of these determinants. The first one will start off with 5 times negative 6 minus 3 times 4. That would be equal to negative 30 subtracted by 12, negative 42. This next one will multiply the 12 and the 6, or should say 12 and the negative 6, minus 24 times 4. That's going to equal to negative 72 minus 96, or negative 168. Now this next one over, we'll multiply the 5 and the 24, minus, multiply the 3 and the 12. So that's going to equal to 120 minus 36. And that's going to equal to 84. So now x is going to be equal to dx over d, so negative 168 divided by negative 42. And that's equal to positive 4. dy is going to equal to 84 divided by negative 42. And that's going to equal to negative 2. So our solution here for x and y would be 4, negative 2.